Welcome everyone to yet another edition of the research workshop series organized by the Research and Publications Office of IIM Ahmedabad. And on behalf of the Research and Publications Office, I welcome you all. And also I'm delighted to, we are delighted to have Professor Vishal Gupta with us. And we have a very, healthy turnout and other participants are still joining. The title of today's workshop is Conditional Process Analysis in the Social Sciences. And Professor Vishal Gupta is going to, has organized and will lead this workshop. As you all know, but I would briefly introduce Professor Gupta. He is an associate professor here at the Indian Institute of Management, Ahmedabad, in the organizational behavior area. Professor Gupta also is the chairperson of the Ashank Desai Center for Leadership and Organizational Development. And he serves as the president of the Indian Academy of Management, which is an affiliate of the Academy of Management in the US. Professor Gupta previously served as a faculty member at IIM Calcutta, and he earned his doctorate from the Indian Institute of Management, Lucknow, specializing in human resources management. Professor Gupta, again, we all know, is widely acclaimed in the field, and among his many awards that he has won, he was one of India's 25 young HR leaders in 2013. He was also recognized as an emerging psychologist by the National Academy of Psychology in India, that's in 2014, and he was also conferred the Young Scientist Award in the social sciences category by the National Academy of Sciences, India, in 2016. So, he has a great deal of experience and expertise, both in academics and practice in this field. His research interests and teaching interests include leadership, justice, creativity and innovation management, research and development management, organizational theory, among others. He's widely published in these domains, and among his many publications, he's published in the Academy of Management Journal, Human Resource Management Journal, International Journal of Human Resource Management, among many other outlets. So again, it's a great delight, Vishal, to have you with us. Before I turn it over to Vishal, just very quickly, this is going to be a 3-hour long workshop, but Professor Gupta has structured it in a way that at around the 4:20 or 4:30 mark, we will have a break of about 15 minutes. In terms of general rules, we would really appreciate if you could turn off your microphones and keep your microphones turned off at all times. And if you have a question, please raise your hand, or you can even type out your question in the chat box, and Professor Gupta will take up the question when he feels it's the right moment to take up those questions. So that's about it. And without further ado, Professor Gupta, over to you.
Thank you. Thank you for having me here and for the very generous introduction, Sandeep. So welcome everybody, and on behalf of IMA, it is a pleasure, and the Research and Publication Department. So what we're going to cover in today's session is something that has become quite popular in the social sciences journals, especially journals that are focused in the domains of OB, HR, communication, strategy, marketing. We call this technique today, or the idea today, as conditional process models. Some of you would have also come across papers. So this is a broader category. This is called as moderated mediations also. So we talk about, or we have learned if we have been exposed to these ideas of mediation, moderation, the phenomena. But today we actually talk about even beyond simple testing of mediations and moderation. And this category, this set of models are called as conditional process models. So what I'm going to do in today's class is maybe we'll spend the first 30 to 45 minutes reviewing and going over the theory about these models. Okay, we'll cover the theoretical understanding of these ideas of mediations and moderations and then conditional models. And then maybe in the second part of a workshop, I will demonstrate this idea through a data set. So one of my published papers, I have brought the data set, and then we'll look at the analysis. How do we write it up? How do we analyze that data? And how do we present the results? So that is going to be broadly the way I would like to approach this workshop. So the first thing is, let's spend some time reviewing the theory about these ideas, what we call as mediation, moderation, and conditional models. So I'm just sharing my screen. I hope you will be able to see that. So let me just open my, yeah. Okay, so now what we're going to do is, let's spend some time looking at the understanding of these ideas, which we broadly understand or call as mediation. Okay, so what I'm going to do is we'll look at the theory, the idea about mediation. Okay, so you would have come across one of the simplest models and diagrams that are typically given whenever we talk about a mediation model is something like this. So you have an antecedent variable, okay? You have an antecedent variable, you have a consequent, which is a y, okay? And we have a mediator, as we call it in our discipline, and the diagram is drawn like this. So the coefficients on the paths, the regression coefficients, are listed like this. Okay, so this is a very typically drawn model of, and obviously you have the regression residuals associated with each of these variables. So this is a description of a mediation model. Now, the first thing that I want you to notice, people who are new to this idea, is what is in our research. In our research, the research projects, research papers, when do we talk about doing a mediation analysis, or why should you actually bother about doing a mediation analysis? What kind of research problem, research question does a mediation analysis answer? Okay, so the question that you have in mind that you want to answer using mediation, okay, is, I typically call it the how question. Okay, the how question, or you would also read in different research books, we call it as the process analysis. Okay, understanding the process. Now, if I were to summarize this in one word, I would call this as mediation helps us answer the how question. So if you were not testing mediation, and let's say you were only doing this kind of an analysis, you were only doing testing a path, testing the coefficient between x and y, you were interested in looking at the effect of x on y, you were saying, okay, I want to understand how are x and y related. What is the relationship between the antecedent and the consequent? That is fine. That's a good question to answer, whether these two variables are related or not. But then look at how mediation has helped in the analysis. How has mediation helped you in furthering the question or the research that you were doing? The moment you now bring in the mediator, we are able to understand, okay, there is an impact of x on y, all right, there is an effect of x on y, but then I want to understand underline the word how does x impact y? Okay, now by doing the mediation analysis, I understand that there is a direct effect of x on y. Okay, so I understand that here is a direct effect. Okay, in the terminology of mediation, we call this as a direct effect. That's the direct effect. And then, well, x also impacts y via the mediator, and this is called as, in the terminology, this is called as the indirect effect. So you would, whenever you do mediation, you always talk about, well, there is a direct effect, there is an indirect effect, and then there is a total effect of x on y. Okay, so that is the kind of analysis that you can now do. If we were just doing, just to repeat, if we were just doing the test between x and y, we were saying, well, this is the effect of x on y. But the moment I do mediation, I have broken down the total effect into a direct effect and an indirect effect. Now let me demonstrate how this happens through regression. Okay, so I would simple regressions. Let us try to get a sense of how does this breaking of the total effect into a direct and the total effect really come about. All right, so let us start by writing the equations, okay, the regression equations of these variables. So I say, well, I will write the equation of m as an outcome. So I'm looking at this mediator, okay. So m, I call it as, well, another thing that I'm going to do in this workshop is I'm going to follow the notation that are typically given in the very standard text of Hayes, which talks about mediation and moderation. So in case any of you are familiar or you are reading that text, my analysis, my explanation would be in sync with that book. I will share the link of the book in case you are not familiar. You may want to order it in your library or have a copy of the book. Okay, so let's write the equation. So I say, well, m, there is a constant, and then I call it as a times x plus the residual, the regression residual. Okay, that's the error of the regression. Okay, so this is a very simple regression equation for our mediator m. Okay, m is constant plus a times x plus the error. Similarly, I will write the equation for y. If we were writing the regression equation for y, looking at this diagram, what will it be? Let me call this as constant 1, I1, and I'll call it as I2 plus c dash times x. So that's the coefficient associated with our antecedent x, and b times m. Okay, so that's the coefficient associated with m, and then you have the residual of y. Okay, so this is my first regression equation. This is my second. If I combine these two equations, I can say we get, what do we get here? We get y is equal to I2 times c dash times x plus b times, and I write the equation of m here in the model, and I get I1 plus a times x plus em plus b. Yeah, bm is already done, so what is left is e of y. E of y. Okay, so this becomes the combined equation. Now I can club the common terms. Well, this is a constant. Okay, I2 is a constant. It is a number in our analysis. B is a constant because it is a coefficient. I1 is going to be another constant. So the product of two constants is always a constant, and you add up. So you get a term I2 plus BI1. Okay, so this is one common term that emerges. And then let's take out the terms that are common to x. Okay, so one term is c dash, so I write it here, c dash, and then what I do is it becomes b times a into x, so I'm going to write it as ab times x, and then, well, em and ey, they are both random numbers, they are residuals. Okay, it's a random series, and a constant multiplied with a random series is a random series again. So I can club these and they become my residual of they represent the residual of my overall regression equation. So I can write this equation as some constant I plus c dash plus ab x plus n, a residual. Okay, and let's call it as e of y. Again, this e of y would be different from this e of y, just for notation. Now you see, if we were to do a similar regression between just x and y, okay, if I was to just do one regression, I was interested in looking at how is x related to y. Let's call this constant as coefficient as c. Okay, let's call this path coefficient here as c. What will I get? I will get y is equal to I plus cx plus e of y, some residual associated with y. So if we were to compare these two equations, okay, if you compare these two equations, it can be said, therefore, it can be said that here C, which is called as the total effect, okay, this is the total effect of X on Y, okay, this is the total effect of X on Y. If there was no mediator in the analysis, it was C. What have we done? When we brought the mediator in the model, the coefficient of x is y. So we can say that C here is equal to C dash plus AB, because this is also representing the coefficient of x on y, and this is also representing the coefficient of x on y. And this is the fundamental equation that is written to understand how the effects get broken down when you bring in mediators into your model. So this C dash is called as the direct effect in the presence of the mediator. What is the direct effect of x on y? And this product A to B, this product A into B is called as the indirect effect. So what have we done? There are two things that I would want to mention here. If we go back and look at this model that we started with, what is this? The direct effect is very straightforward. It is C dash. And what is the indirect effect? Indirect effect is the product of all the path coefficients that you meet when you travel from X to Y. Okay, what I have just demonstrated is that how the effect is computed using regression, but pictorially also we start from X, go to M, so that we meet the first coefficient, which is A. We start from M, go to Y, and we meet the second coefficient, which is B, and the product becomes A into B. So there is this indirect effect. What have I achieved by testing this? Up till now, I was only talking about X is related to Y. But now I can say that X is not just related to Y directly, but it has an indirect influence. So for example, if you were to say leadership impacts performance of individuals, of employees, leaders impact performance. Well, that is okay to say leaders impact performance. But what is it that leaders do? What is it that leaders do to actually impact performance? And that is they impact, let's say, justice perceptions. Okay. Leaders impact perceptions of fairness at the workplace. So one of the mechanisms that leaders can deploy to impact performance is to create fair workplaces or to impact perceptions of fairness for employees, and that may have an indirect influence on performance. So that is what the mediation tries to do or tries to achieve when we are doing this kind of an analysis. Okay, so if you are doing your mediation papers, okay, these are fundamental building blocks for conditional models. If you are going to do your mediation models, you will have to prove what is the test of mediation. The test of mediation in any research that you do, in any research paper where you are going to you are talking about mediation models. In those papers, one is, yes, you talk about whether A is significant, B is significant. You will get it through your regression equations, right? You can find out whether my coefficient A is significant, whether my coefficient B is significant, and that is good. And your C dash, which is the direct effect. But then that is not the test of mediation. Okay, if you just leave it at that, journals and reviewers will come back to you and say, well, that is not the test of mediation. So what is it that you will have to do when you are going to test for mediation, or when you are writing about mediation? You will have to show that this product, I'm calling it as the true, that is of the population, A true A and true B, that is the product A into B in the population will be 0, or will it be different from 0? This is A and B here. I'm denoting these are sample coefficients. But what about the population? In the population, will this term be, the product would be 0 or not? Okay, so that is what you will have to prove. You will have to talk about, irrespective of what happens to your direct effect. We are not concerned with what is happening to direct effect here. If you have to talk about mediation, that there is a significant mediation in my research, there is a significant mediation in happening here, you will have to talk about what is happening to your indirect effect. Is the indirect effect significant or not? Now, how do you do it? I will not go into detail here because we don't have the time. There are two ways to test the significance of indirect effect. The first one is called as the Sobel's t-test, which is given by t is equal to a into b divided by the standard error of the product term ab. Okay, so you know a, and here a and b, mind you, they are unstandardized coefficient, unstandardized regression coefficient. Okay, you will get it from your analysis here. Okay, from your regression test, you will then take the product, okay, a into b, and standard error ab is not given, so there is a formula. So we say a square into standard error of b square plus b square standard error of a square. So this is the formula. Again, we don't have to compute it. Today we have softwares that give us these results automatically. Okay, and so this has been found. This follows a t distribution with n minus k minus 1 degrees of freedom. And so you look at the p-value and test it against your alpha and make the conclusion whether your indirect effect is significant or not. Okay, but then there are criticisms of Sobel's t-test because simulation studies, Monte Carlo studies have shown that this product, okay, this test is assuming that the product A into B follows a normal distribution, okay, which have been found to be violated. Okay, that does not hold good. Studies have shown. So the second way, which we will also see when we will do our analysis, is what we call as bootstrapping. Okay, bootstrapping method. So today we typically, whenever there are doubts about our normality assumptions, we typically report not just the normal theory test, but we also report the bootstrap results in order to account for whether our coefficients or the indirect effects are significant or not. Okay, so two things that we will keep in mind through what I have said so far is mediation helps us answer the how question, understand the process. It helps us break the total effect into the direct and the indirect effect. And then whenever you are writing or going to talk about mediations in your research paper, you will have to show that the indirect effect is significant. Okay, what happens to the direct effect is not important. You have to prove, you have to show through your analysis that the A into B is significant. All right. Now, the good thing about, if once you understand this simple mediation model, actually, and again, I will not do it because we don't have, that is not typically the focus here. But this idea of mediation, of this kind of analysis, can be extended to multiple mediator models also. Okay, the way of analyzing this this model that we have just done. So again, today researchers they look at multiple mediators, okay, testing the process, trying to understand the process. So you have not just one mediator, you may have more than one mediator, okay, and this is your direct path. We call this as C dash. This is, let's call this as coefficient A1, B1. Let's call this as A2, B2. Okay, so now this is a multiple mediator. And by the way, this is called as a parallel mediator. mediator. So you may read some papers, some of you may be working on these kinds of models. This is called as a parallel mediator model. Okay, now if you have understood the first model that we just did, the one mediator model, understanding multiple mediator models is a cakewalk. You can say, what is the direct effect? Well, my direct effect in this model is C dash. This is my direct effect in the presence of mediator. The indirect effects. Okay, now there are going to be multiple indirect effects because there are multiple mediators. Okay, so you have one path. You start from X, go to Y via M1. Okay, so it becomes A1 times B1. Okay, the other path goes via the second mediator. Okay, and so you have another indirect effect, that is A2 times B2. And so your total effect now here. Okay, so your total effect is given by C dash plus A1 B1 plus A2 B2. Okay, and you can test, you will have to show that these indirect effects are significant in order to prove that your mediator M1 and mediator M2 significantly mediate the model that you are looking at, the process or the relationship between X and Y. Okay, so this is called as a parallel mediator model. Then there are another kinds of papers that are being done today, okay, and they are becoming more popular. They are called as sequential mediations, okay, sequential mediator models, okay. Sequential mediator models. Now, what happens in a sequential mediator model is you have X, okay, and you are testing its relationship with Y, okay, so I call this X and Y, and then now I have again, let's take up the case of two mediators, so M1 and then M2. Now what happens is these are arranged sequentially. So X is related to M1, M1 is related to M2, and M2 is related to Y. Okay, so this is, or here X causes M1, M1 causes M2, M2 causes Y. And then you also have the direct paths emerging from these variables. So this is called as a sequential mediator model where they are not arranged parallelly. They are in this model, they are parallel, right? Here, both these mediators are not related to each other. But here there is a relationship between the two mediators also. So we call these as A1, okay? This is A2, this is B1, this is B2, this is C dash, and then let's call this as path from 2 to path regress D to 1, so path from 1 to 2. So what is the direct effect again? The direct effect here, these can all be proved through regression, writing regression equations, okay? And there are now going to be 3 indirect effects, okay? So the first indirect effect is going to be this. The second indirect effect is going to be this. And then the third indirect effect is going to be all the way from X to M1 to M2 to Y. Okay, so that is how we understand, and once you get your regression output, you can do this computation yourself to figure out what would be the indirect effect between the X and Y. So this is the effect of X. What is indirect effect? Indirect effect is nothing but the effect of X via M1 and M2, or via M1, just via M1, just via M2, or both M1 and M2. So there are going to be here three indirect effects, A1, B1, A2, B2, and then A1 product D21 product B2. Okay, and you can again test the significance of each one of these using either the Sobel test or the bootstrap method and report that these results or these coefficients or these effects are significant, and therefore there is an indirect effect. There is a via effect of X through these mediators. Okay, so that's the whole thing that we would want to look at when we talk about mediation. Now let's come to the second very important phenomena that we look at, which is called as moderation. Okay, so this was all about mediation. Now we talk about what is moderation. If I were to summarize the whole idea of moderation testing or moderation models, I will use the word when. Okay, so remember the mediation asks the question how. Okay, how does X impact Y? How is the influence of X happening on Y? So what are the via medium? What are the mediating variables? What is the process through which X is impacting Y? In this case, what we are doing is we are not looking at breaking down the total effect. Rather, we are looking at when will the effect of X on Y be different. Okay, in mediation, we said C is equal to C dash plus AB. Okay, so we said that the total effect does not change because of the mediator. This will add up to still remain C, the total effect. That is what was happening in mediation. But now in moderation, what we are going to say is, or what we are going to do is, when will the total effect itself change? How will or what would be that boundary condition? So we typically call this as exploring boundary conditions in our processes, in our phenomena. Quantitatively, we call it as, what is the boundary condition for my phenomena? What is the boundary condition for my relationship between X and Y? Now, the first thing that you should remember or you should note is when we talk about moderation, okay, a moderation model is always drawn like this. I review a lot of papers where people are confused between the representation of moderation and mediation models. Okay, so they will talk about a mediation model but draw it like this, or they will talk about moderation but they will draw it like a mediator model. So please note that this is how a moderation model is conceptually represented. Okay, this is the conceptual representation of a moderator model, okay, of a moderation. Do not get confused between a moderator representation and a mediation representation. Okay, so if this is the conceptual representation, how is this studied? What is the statistical, or how will we understand it, okay, in our statistical analysis? So we call it as the statistical diagram or statistical representation. And so you break this, or you open up this model, okay, you have X, you have y, and you have a path from M to y, and then you also regress y on x into M. You regress y on the product of x and M. Okay, and we'll write these coefficients. Let's write these coefficients as b1, b2, b3. This is the error associated with. Okay, so what is the equation? How will I write the regression equation? I will write it as y is equal to some constant I plus b1 times x, b2 times the moderator of my model, and then b3 times x into M plus the residual of the regression E of y. Okay, so this is the representation. If I combine the terms, so I can write it as I plus b2 times M plus b1 plus taking out the terms common with x, so I call it as b1 plus b3 M times x plus E of y. Okay, now look at this, and this is where it becomes really interesting when we start talking about moderations. Okay, look at what has happened. If I were to say what is the effect, so let me denote the effect of x on y by theta. Okay, so I call it as the effect of x on y. Now it has become what is the regression coefficient? It is b1 plus b3 times M. b1 plus b3 times M. Okay, so again, emphasizing that when we were talking about mediation, we always said that the total will add up. The direct and the indirect will add up to be C. Okay, so what we are doing in mediation, we are just breaking down into two terms, the direct and the indirect effect. But then what does moderation do? Moderation says no, I'm not just looking at breaking up of the term. What am I doing here? I am saying that the effect of x on y has now become conditional on M. Okay, so we call this as the conditional effect. The conditional effect of x on y. Okay, so that is my conditional effect. So the effect that x was having on y. And this is a beautiful idea to do in research. You see, there are, and especially in our discipline, in management, in social sciences, typically what we do is we study relationships, we talk about theoretical frameworks. Now, what is moderation helping us to think? Moderation is telling us, well, you see, x to y is related. We know from prior literature. We know that x to y is related in maybe in Western context. This is how it happens. But then when I'm talking about India, when I'm talking about my specific context, either industry context, either work context, cultures, okay, different cultural context, what I am saying that the relationship of x and y is not what we have found in the Western context. Rather, there is a moderator. There is that moderator could be anything. It could be individual personality. It could be, as I said, cultures. It could be industry context, etc., etc. There are variables that will change how X and Y are related. They can either enhance the effect, they can either enhance the relationship, then I also diminish the relationship between X and Y. And that's a powerful idea, because what you are saying is, I am not denying the theory. I am not denying the theory. I'm not saying that the theory is junk. What am I saying is, while agreeing that X and Y are related, I am adding a nuance to the theory. I am adding a condition. I'm adding a boundary condition to this theory, to this argument, that X and Y are related, but in my context, it may be actually more pronounced. It may be pronounced, it may be higher, or it may be lesser, and so on. So remember, okay, remember, in moderation, your effect of X on Y will always change, Whereas in mediation, it will always remain the same. Mediation helps you partial out the effect, break down the total effect into direct and indirect. Moderation actually helps you figure out when will the effect be pronounced or not. Okay, so that is one thing. Now, what is the test of moderation? Like we did the test of mediation, how or when will you say that there is a moderation in my model? There is a moderation in my analysis, okay, in my research that I am doing, in my data. Okay, so we call it as test of moderation. So if you look at this equation that we have written here, okay, this equation that we have here, when will the effect be conditional? When will the effect of X on Y become conditional on M? It will become conditional on M when my B3 is significant. My B3 coefficient is significant in the analysis. If B3 is not significant, if, for example, if B3 was to be tied at 0, what will happen? It will become theta X to Y would become B1. Is this conditional on M? There is no M term here. Okay, there is no M term. Therefore, the effect is unconditional. Okay, it is always going to be B1. It is B1. It's a constant B1. So the moderation exists only and only if your B3 is significant. Okay, the coefficient of, and what is B3? The coefficient of the interaction term. Okay, interaction term is significant. Remember, okay, I'm repeating, remember, irrespective of what is happening to B1 and B2, irrespective of what happens to B1 and B2, moderation will exist if B3 is significant. So a lot of people, students that I work with and other researchers, they talk to me and say, well, Professor, the coefficient of X or the moderator is not significant, and so my moderation is not going to be significant. Well, that does not matter. What happens to B1 and B2 does not matter. Okay, you've got to be interested in checking what is happening to the interaction term, because that is going to change the effect. So the test of moderation is only and only if your population parameter B3 is different from 0, is not equal to 0. That is when we will say there is a moderation. Okay, and that is very simple. Here you don't have to do any anything. The regression output will tell you whether this coefficient is significant or not. Okay, just one last thing while we are on moderation, you will also have to do one more thing whenever you do a moderation paper. You would see that in a moderation paper, there is always a plot that is done. Okay, we call this as moderation plots or interaction plots. Any paper in any discipline, OBHR, marketing, strategy, communication, any of these disciplines, whenever you talk about moderation, you will always have to plot how is the relationship between X and Y changing for different values of moderation. So we call this as an interaction plot. Okay, interaction or moderation. Okay, and so there would be no moderation paper is complete without such plots. So what you do is you plot the line. Okay, so I say, well, this is my line when I say y is equal to I plus b1 x plus e of y. This is when m was 0. Let's say moderator was 0. And then I plot another line here and I call it as, this becomes y is equal to I plus b2. So this becomes my intercept of the line and I get b1 plus b3 x ey. This is when m is equal to 1. I'm assuming your moderator is dichotomous. It takes two values, 0 and 1. So if you plug it in this line, b2m, okay, this was one term, and then we got b1 plus b3m times x plus e of y. So you can get these two lines. Y when m is equal to 0 is I plus b1x, and y when m is equal to 1, you get b1 plus b2, b1 plus b3 times x. Obviously, all of this plot that I have shown are with an assumption that all these coefficients are positive. Okay, they are all greater than 0. If these polarities change, if the signs change, if they become negative, then your plots will change. Okay, so this is your constant I. This difference between the two lines is going to be b2. Okay, the slope of this line is b1, and the slope of this line is b1 plus b3. Okay, that is, so you will have to show, and the visual test of moderation is that the two lines diverge or converge. They are not parallel. Okay, they should not be parallel. If they are parallel, then it means that this term is 0. This term is not significant, and therefore the lines are parallel to each other. Then there is no moderation effect that is happening here. Okay, so this is all that you would do, or you will have to do whenever you are going to do moderation paper. So what we've done so far is we've tried to cover the mediation idea. Okay, so the mediation helps us answer how, moderation helps us answer when in our research. Now, with this background, with this foundation, let us come to the idea that we are all here for, which is the combination of these two terms and these two ideas, which combined today in research, they are called as moderated mediations. Okay, so understanding of mediation and moderation is important in order to understand this term, which we call as moderated mediation. Okay, this is also called as conditional process analysis. Conditional process analysis. Now, if you have understood mediation and moderation, you would be able to understand what are we talking about here. We are talking about process analysis. Okay, so what was process analysis? I just told you process analysis is mediation. Okay, so mediation is actually telling us, helping us understand the process. Okay, now moderation talks about the boundary conditions. Okay, the idea of moderation, which we just covered, is moderation talks about the boundary conditions for our phenomena, for our relationships that we are trying to test. When you combine both these ideas, when you relate both these ideas, you get moderated mediation, or what we call as conditional process analysis. Okay, now let me demonstrate what is it that I have in mind and how does this actually work. So let's say we are talking about our original relationship that we wanted to understand. How is X related to Y? What is the relationship between X and Y? So we test this path. Okay, we wanted to understand the process, so therefore we brought in our mediator. Okay, now what have we done? We have done the process analysis bit. We are now it is now possible to understand what is going to be my direct effect, what is going to be my indirect effect. So I'm now doing process analysis. But then I'm saying that the process is also conditional. The process is also conditional. There is the mediated, the mediation is also moderated. Okay, the mediation is moderated. If I draw an arrow like this, I'm saying now, let's say I will give you multiple scenarios here. Okay, let's begin with a simple model here, where we are saying, let's assume there is a variable W that moderates the path from X to M. Okay, it can moderate other paths also, but here I'm, for simplicity, I'm just assuming that the variable moderates this path between X and M. So what have we done? You see, this becomes a representation of, there is a mediation, okay, which was here. This is our mediation, and here what have we done? We have brought in the idea of moderation. So there is a combination of, so this was our mediation analysis, and this is the moderation. Okay, now what am I trying to achieve? Why am I drawing these fancy diagrams? What is it that I am trying to do in my research? Why should we even be bothered about drawing or doing such kind of analysis? So let us see what happens if I were to draw this kind of a diagram. Okay, what is the kind of question that I'm trying to answer? What is your research question for which you should actually be doing conditional process analysis? Why should you be even bothered about this kind of a diagram? Okay. So if I say, let's say we have X, we have our variable Y. Okay, this was our conceptual diagram. Let's try to do the derivation. Let's try to do the regression equations here and see what is it that we are getting. Okay. Let us open this moderation, and we have seen that whenever there is a moderator, we always draw a path from W, from the moderator, and then we also bring in the product term X into W. Correct? This is what we had done. If you remember, if you look up your notes, or if you remember, we had opened up the conceptual diagram and we had drawn the path from moderator to the outcome, and then the interaction of the antecedent and the moderator to the outcome. So here, because W is moderating the relationship between X and M, this is how I draw it. And then the other path, I draw it as it is. Okay, so this path I call as C dash, as I was calling earlier. This path I call as B. Okay, this coefficient was A. Now it has been broken down or opened up into three parts. So I call it as A1, A2, and A3. This is how I write this, or this is the statistical representation. Diagram that I draw. Okay. Now, if I were to write my equations here, what will I say? I will say, well, M is equal to I1, some constant plus A1x, A2W, A3x into W plus the residual associated with the outcome. And then, so I can simplify this and I can say Y is equal to I1 plus A2W plus A1 plus A3 times W multiplied with X and E of M. So this becomes my first equation here. Then what do? I write my second equation, which is the outcome Y, and I say Y is equal to some constant I2 plus B times M plus C dash times X plus the residual associated with the outcome Y. Now, if I combine these two equations, what do I get? I get, combining 1 and 2, we get M is equal, Y is equal to, I'm substituting M in Y. What I get is I2 plus, now let's multiply B with this equation, M, which is I1 plus A2W plus A1, let me multiply whole of this, A1 plus A3W times X plus E of M plus C dash X plus E of Y. Okay. So what do you get if you expand this equation? You get I2 plus B times I1 plus A2W. Okay. So this becomes one term. Okay. This is for different values of W, we will get different intercepts. So this becomes the common, the intercept term. And then what do? I get B times A1 plus A3W And I'm going to bring in C also because I want to club the terms common to X. So I say plus C dash here. This is X. Okay. And I get the residuals E of Y plus B times E of M. This is what I get when I start to solve my regression, my equation here. So I can write my overall in this form, y is equal to I plus Cx plus Ey. And I can say that my C here is equal to C dash plus B times A1 plus A3 W. Now this is the key result that we were doing all this thing for. Okay. Now this equation, the first thing that you should look at is that this is a mediation equation, right? So what have we said? We have said that the total effect C is broken down into a direct effect. There is a direct effect C dash, and there is, so this is the direct effect of X on Y, and this term is the indirect effect of X on Y. And not just that, this indirect effect of X on Y is actually conditional upon on W. If you see, what have we got? This indirect effect now is conditional upon X. So what is the research question that we have answered? What is the research question that we have answered now, or we are trying to answer, or what is it that we are trying to achieve through these conditional process models? Is we are saying that, well, X impacts Y via this term, via the mediator. Okay, so there is an indirect effect of X on Y via the mediator. That is okay, right? So that is the indirect effect here. But then indirect effect also has a boundary condition. It is not unconditional. Under certain circumstances, the indirect effect can become higher. It can also become lesser. What is the indirect effect here? The indirect effect has become A1 plus A3 times W multiplied with B. When, let's assume W to be dichotomous, so it can take two values. So when W is equal to 0, indirect effect is A1B. A1B. When W is 1, you get your indirect effect as A1 plus A3 times B. So now we are saying, what have we done? We have identified, or we have discovered one more insight about our phenomena. What is the insight about the phenomena? The insight is that the process that I was talking about, the indirect effect that I was talking about, that also does not remain unconditional. If I have one particular condition, then X has a greater impact, greater indirect impact on Y via my mediator. Under other circumstances, X has a lower indirect effect. Let's X has a lower via medium effect on Y. So what is it that the conditional process model helps us achieve? So you can now visualize in your, just look at, think about this term, conditional process analysis. So we are doing process analysis through the mediation, and then we add the condition to the mediation, condition to the process, and so it becomes conditional process now. It has become conditional indirect effect. Okay, or we in our research papers, you would, and I will show you some papers of mine, we call these as moderated mediation models, okay, where the indirect effect is moderate. So let us look at another example, okay, let us look at another example before we take a break, and then we'll come back and do an example, okay. Let's look at this model. Okay, so I have X, I have Y, okay, I have this mediator. So I'm just taking a simple example, so that simple one mediation example, not the parallel, but these ideas can be extended to multiple mediator models as well. Okay, this is A, this is C dash, this is B. Okay, now I want all of you to do this diagram. Okay, draw this diagram and let us try to analyze what will be the direct and the conditional indirect effect here. Okay, now this is the concept, this is how you will draw in your research papers. Okay, when you will be, so this is the conceptual diagram. Now let's see how we will open this up and draw our statistical diagram. Okay, what will be the equivalent statistical diagram for representation of this model? Okay, so we have X, we have M. Remember, when you have moderation, how will you open it up? So you have this Y here, the path from the mediator comes, and then we have the moderator. So we will have the path from the moderator, and we will have path from the interaction term M into B. Right? Remember how we used to open the moderation, okay, the moderator diagrams. Okay, so you have the path from X, you have the path from the moderator, and you have the path from M into, or the antecedent and the moderator, the product of the antecedent and the moderator. So we call this as A, we call this as C dash. Okay, and because this is B, so now I open it up and I call it as B1, B2, and B3, these coefficients. Okay, now if I were to now simply show you the regression equations here, what will it be? M will be very straightforward, so it will be I1 plus A times X plus E of M. No difficulties, no complexities here, very simple, one variable, I1 plus AX plus E of M. And then you have Y, which is I2 plus C dash X, okay, the direct effect. And now you have B1M, B2V, and B3 times M into okay, plus E of Y. Okay, so you have this B1 plus B3V times M plus B2V plus E of Y. And now what we are going to do is we are going to substitute 1 into, okay, so we are going to put in key in the equation of M. So what is it that we get? Y is equal to I2 plus C dash X plus B1 plus B3V multiplied with I1 plus AX plus EM plus B2V plus E of E of Y. Okay. Now let's open this up. So we'll keep putting together. So we'll put this term together with I2. So we'll call it as I1 times B1 plus B3V. Okay, so this is one term now. Then let's put the term with X together. So it will be C dash, which comes here, plus A times B1 plus B3V. Okay, whole times X. Okay, and here, yes, B2V also goes here. B2V will also come here. And then you have the error terms EY plus EM, B1 plus B3. Okay, now if we were to compare this equation with our overall total effect equation, Cx plus E of Y, what will it become? C is equal to C dash plus A times B1 plus B3V. This is the key result here in this kind of a model. So what have we done? We have got the direct effect is this is the direct effect. And now this term represents the conditional indirect effect. This term represents now the conditional indirect effect. So there is not just one indirect effect. Now this indirect effect is now conditional upon the value of V, the value that V takes. Okay, so your indirect effect, when V is equal to 0, what will it be? A times B1. Indirect effect, when V is 1, V becomes 1, or V takes a value of 1, what will it be? It becomes A times B1 plus B3. So again, what are we trying to do now? We are saying that our indirect effect, our process now, okay, the understanding of process, the process that we are looking at is not unconditional. Okay, the indirect effect is not unconditional. It is actually conditional upon the value that V is going to take, because V moderates this path. Okay, now just an interesting fact, or just for your clarification, tell me, all of you, if you are with me up till now, tell me if you have a model like this. If you have a model like this, okay, is this conditional process analysis? Is this a conditional process model? Is this an example of moderated mediation?
No.
This is not.
No.
This is Yes, yes, you are all. Yes, I'm happy you are with me. This will not be called as conditional process analysis, because what you are doing, you are only talking about the moderation of the direct path. So this is not moderated mediation. This is not a class of moderated mediation. This is only talking, if you were to open this up, okay, if this is our conceptual diagram, if this is our CD conceptual diagram, the statistical diagram is going to be X to M to Y, okay, then you will have an effect from W to Y, and you will have an effect from X into W to Y. This will continue to be A, this will continue to be B. We can write this as C1, C2, C3. Okay, but here there is the indirect effect. Indirect effect here will be only A into B. You will have a conditional direct effect, that is all right. You will have a conditional direct effect, which I can tell you will be, you can write down the equation and verify, this will be your direct effect, C1 plus C3W. This will be the theta X to Y conditional upon W, but you will not have a conditional indirect effect, and therefore this will not be an example of moderated mediation. Let us do one last example, and that would cover up the theory that I wanted to talk to you here. Let's look at this one last diagram, and I will encourage all of you to try to solve it on your notebooks, okay? And let us solve it together. So I have this model now. You may see some papers talking about models like this. X to M to Y, okay? So you have, this is our indirect effect, sorry, this is our direct effect, C dash, and then I have a W here, I have a V here. Okay, this is my concept. So we have so far seen with only W, with only V, but this is the last kind where even you can have moderators on both paths. Okay, you can have moderators on both the paths. And how will it look like? Okay, so the first thing that we do in always is we start by doing our statistical diagram. So let's open how the regression equations will look like. Okay, so we write X to M, W to M, and then X into W to M. Okay, so this is my X, W, and X into W. Then I write my path from M to Y. So this is Y. Then I draw a path from V, and I draw a path from M into V. So I open this moderator also, and I call this, so I call this as A1, A2, A3. These coefficients, I call this as B1, B2, and B3. Okay, so I'm just, what we have been doing so far, I'm just replicating it for both sides. And this effect continues to remain C dash. Okay, so what is it that we can write? So M we can write here is I plus I1 plus A1 plus A3 W times X plus A2. Okay, let me write it. Let me not. So let me write it as A1X plus A2W plus A3X into W plus E of M So it becomes, my M becomes I1 plus A2W, A1 plus A3 times X. So I can say my conditional effect of X on M, okay, which is conditional on W, can be written as A1 plus A3, right? This is my effect of X on M, and that is conditional on W, okay? So this becomes my first equation here. Similarly, I can say that Y is equal to I2 plus C dash X plus B1M, B2V, B3M into V, that is another interaction term, and then E of Y. So if we club the terms together, B2V comes together here, okay, then we have the C dash X term, and I can say B1 plus B3V times M plus E of. Okay, so just simplifying this equation. So what is the theta M to Y? Okay, the effect of M to Y. Now this is conditional on V, and that is given by B1, this term, B1 plus B3. B1 plus B3. So this is the effect of X on Y, X on M is this, effect of M to Y is this. So what is the total indirect effect? The total indirect effect of theta X to Y conditional on W comma V can be written as theta X to M conditional on W multiplied with theta M to Y conditional on V. So because we have seen what is our indirect effect is always the product of the effect of X to M and then M to Y. Okay, so what is it going to be? It is going to be a product of A1 plus A3W multiplied with B1 plus B3V. And this is now your indirect effect, which is conditional on two moderators. Two moderators, okay, A1 plus A3W, B1 plus B3, B1 plus B3V, and your direct effect continues to remain C. What is your total effect? It is going to be C plus A1 plus A3W and B1 plus B3. This becomes our total effect. So what have we got? Because there are two moderators, you have again a conditional indirect effect, and which is denoted by this. This is our conditional indirect effect. So again, to emphasize, we talked about mediation. Mediation helps us talk about the process, the how. Moderation helps us talk about the condition, the when, okay? And conditional process talks about when is the indirect changing, or when will the indirect itself change depending upon the condition, which is the moderation or the moderator that is there. Either it could be from X to M, it could be from M to Y, or it could be at both x to m and m to y. And then you will have, in all these cases, you have conditional process, conditional indirect effect or moderated mediation. Okay, so let us take a break here. This is all that I would like to say in terms of the theory. Now what we will do is we will come back. Okay, it is about 4:35. Let us come back at 4:50. Okay, in about 15 minutes time. And what I'm going to do is I'm going to upload in the chat a zipped file. Okay, so in the 15 minutes, I will request all of you to please download that zip file. Okay, and then I will demonstrate working on SPSS. Okay, so I will request all of you, in case you have SPSS installed on your machines, you may download the files, launch your SPSS, and then I will demonstrate how do you actually do this and how do you, we'll take up a data, we'll look at the result, I will tell you how to analyze it, how to interpret it, and I will share with you in that zip. I will be sharing some papers, you can read further on. Yeah, okay, so let us take a break and we'll come back at 4:50. So try downloading the file. I have put it on as a zip file in the chat window also, and also this link, you can click on the link and you can check. Okay, Sushant, check again, you should have access. Okay, so let me just explain what is there in the folder, and then you can, when you go back, you can try out these things at your end. So there are few papers initially. So one of the papers that is, let me share my screen. So if you look at this folder that I have shared with you all, okay, there are some papers. The first one is the original Barron and Canny paper, which became a seminal article where the idea of mediation, okay, moderations, how it works, was talked about. So you can keep that as a reference read. Then I have given you 3 papers of mine, which are about moderated mediation, okay, and we will be looking at data of one of these models. So now these models should be familiar to you. Okay, so you can look at this variable which moderates one path, okay, from the mediator to the outcome. It is also moderating the direct path, but the moderation of the direct path is not moderated mediation. The moderation of this path is what will lead to the moderated mediation model. There is another paper, and this is the data that we are going to do in today's, we are going to do now. Okay, so this was a paper that we published, and here we are going to look at, again, you see this variable, okay, is moderating both the path from X to the mediator and also from mediator to the 2 outcomes. So it is the same moderator moderating both sides of the mediation model. Okay. And then there is one, again, another reference read. So you can again look at this diagram. So you would see here again, there is this kind of a moderated mediation analysis that has taken place. Okay, right. Now, what I have done is I have shared with you, as I mentioned, I am following this book, and the file, way to solve this in the demonstration in the class that I'm going to do is basically the first edition of the book. Okay, so there is a macro that has been created for SPSS. The macro itself has undergone many changes, so it is now in its 4th version. What I have done here in this folder is I have shared with you the macro here. Okay, this is the macro.spd file, which is the 2nd version. So it is not the latest version. Okay, so this is only for demonstration purposes. I will strongly recommend you can order this book for your institute library. This is for our analysis, for our work. We are going to work with this process macro in SPSS. Okay, so let me show you what is the problem that we are going to look at in our session. And as I mentioned, I am having this paper as reference. You can go back and read this paper also in detail. So I have taken a part of the data that I used in this paper. So the model that we are going to test is we have an antecedent variable. People who are familiar with OBHR discipline, we have a construct called as perceived organizational support. So the individuals respond how much do they believe or perceive the organization being supportive for their needs for the work. So we are hypothesizing, I am hypothesizing here that affective commitment, individuals' affective commitment mediates the relationship between perceived organization support and organization citizenship behavior. So the argument here is that people who believe that the organization supports them are more likely to engage in citizenship behavior. Another OB construct, okay, they will show greater helping citizenship or helping behaviors, okay, and they will be willing to go out of their roles to help to do things for the organization. So that is the direct relationship, and I am arguing that what explains this is basically the commitment, the emotional, the affective commitment that they feel towards the organization. And this was the data that we have. This was a nurses data. So we were talking about in this research for a nursing, in a nursing hospital context, how would this work? Okay, so that's the first hypothesis. Now, the second hypothesis is with this mediation, we are hypothesizing that there is a construct called a psychological contract breach. Okay, so that means every employee, so in this case, nurses, when they start working in hospitals, there is a psychological contract. There are certain conditions that they believe the organization would fulfill. There is a kind of a contract that is made. Now, if there is a contract breach, if the individual believes that there has been a contract breach, it will moderate the direct relationship, first of all. So we are saying that the relationship between organization support and citizenship behavior will moderate such that, okay, this is how a moderation hypothesis is framed, such that the relationship will be more positive when psychological contract breach is low, which is quite intuitive. If I believe that there has been a contract violation, okay, the relationship between POS and citizenship will be weaker. And if there has been low psychological contract breach, then the relationship will be positive, more positive. And then the third one, so this is the H2 is the moderation hypothesis, the direct path moderation. And now comes the conditional process. So what are we saying? We are saying that psychological contract breach will moderate the mediated relationship. Please look at the wordings here. Here it was directly will moderate the relationship. So we are talking about the direct relationship. Now we are saying it will moderate the mediated relationship between POS and OCB via affective commitment, such that this relationship will be more positive when psychological contract breach is low. So we are saying the mediated relationship between POS and OCB via affective commitment will be stronger, more positive when psychological contract breach is low. Okay, so the indirect, not just the direct effect, will be stronger when psychological contract breach is low. Even the indirect effect will be stronger. Okay, so it will explain, the process can be explained much better. The indirect effect will be stronger when the psychological contract breach is low. Okay, so I have given you this data file. Okay, this is the data. Okay, you have gender, age, qualification, and experience as the control variables, and then I have just given you the aggregated variables here. POS, AC. POS is perceived organization support, AC is affective commitment, OCB is citizenship behavior, and PCB is psychological contract breach. There is a file in this folder, data1.docx, which actually shows you the scales. So it was not just unidimensional, as in we used multiple items. So and these are the references. Psychological contract breach was measured using these items, and so on. Okay, so you can actually just go over the paper or this document. So this is showing. What I have given you is just the aggregated variable here. Okay. All right. And then there is a data file, data.sav, which is the SPSS data file. Okay. This is the data file in which we are going to work. Okay. So let us come to this data file, everybody. And
sorry to interrupt you, but we are unable to access the folder.
Still? Okay, let me. Okay, let me just check. Okay, please tell me if it is accessible now. This is the link.
Yes, Professor. Now it is accessible. Thank you so much.
Okay, good. Okay, so take a minute, everybody. I'm waiting for you. You can download and unzip, and you can see the files. Please use these files for your learning purpose. Okay, especially the process. This is for your. Don't pass it on, because as I said, the latest version is different. I'm just, if you buy the latest book, this process would not even be relevant. So this process is relevant with the first edition of the book that came out. Okay. I have created equivalent scripts in R, but anyways, we don't have the time to look at R here. So we'll look at SPSS. And okay, so we have this data now. Everybody open, and you can so yeah, I'm moving ahead for benefit of everybody. Okay. So we have all these variables with us. We have our 4 control variables, the demographics, okay, age, qualification of individuals, their experience, and then the 4 POS, AC, OCB, and PCB. Okay, and then I will tell you what have I done with the 3 remaining variables. So these are the original. In the Excel file, you will find only these 4 variables. Okay, so the first hypothesis that we want to test is we want to go back and look at the mediation hypothesis. Okay, now Barron and Kenny, if you read Barron and Kenny, Barron and Kenny, they talk about 3 initial conditions before you actually test mediation. They say that, well, you should test the relationship between the antecedent and the mediator. So you should test whether X is related to M. Then you should test whether M is related to Y. And yes, the first condition they say is X should be related to Y in the first place. Then only, because if there is a relationship between X and Y, then only it makes sense to test the process. However, this thinking has been challenged now, and people don't research. If you read today literature, even if there is the total effect may be non-significant. Okay, the total effect between X and Y is non-significant. Today, researchers still find use of testing the mediation. So they still find use of testing the process. So the point that I'm trying to make here is, even if the total effect, when you say, so Barron and Kenny said, well, my POS should have a relationship with OCB. If not, I should not go ahead and test the mediation because there is no total effect. Okay. But now what we say is, well, your total effect may be non-significant, but still it may make sense to find out what is the process through which this can positively impact. What is the process through which it can negatively impact? So people now don't give too much of importance to the first condition, which was the total effects condition, but the other 2 conditions still hold. That is, my X should be related to the mediator and the mediator should be related to Y. So that is something that we should be looking at. Okay, so now what we will do is we will test this using a normal regression, and I will show you how to do the equivalent using the process macro that has been given in this. So the first thing is we are doing normal regressions, okay, the simple thing. So we'll go to analyze and then linear regression, okay, and you will have a window like this opens up. We select our controls, okay, so the gender, age, qualification, experience, we use these, okay. In case you are not interested, you again control variables, it has to be theoretically driven. I am here including them, but if you in your research you do not find them to be useful and theoretically relevant, you should not be doing it. Then we are looking at the relationship between the mediator and the antecedent. So the mediator is affective commitment and the antecedent is perceived organizational support. Okay. And then statistics here, there's nothing much we want to report apart from the optional already done things. So we just let it be as it is, and then I paste the syntax. So not many of you may be aware that SPSS also maintains a scripting platform, okay, where you can keep storing the commands that you are running. And this is what I typically practice and I recommend to all researchers, is because it gives you a log of what are the commands you have run. Okay, so and you can give comments here. So I'm saying I'm doing the regression of AC. Okay, I'm doing the regression of POS to AC. Okay, so this is the regression that I am doing here. Select this and run this. Okay, so this green triangle here shows you run selection. Okay, so when you run this, you will get an output here which shows the R square is 0.45, that is 45% variance explained. And this is the F of the regression. The F of the regression is significant, which means that there would be at least one variable that would be significant. We go down, we look at the controls, not many are significant. Actually, none of these controls are significant. However, our POS, okay, the variable of our interest, which is the X variable, okay, is highly significant. It is significant at P less than 0.001. Okay, this is how you write. Do not write in your research paper P is equal to 0.000. Okay, that is wrong. You should write P less than 0.001. So the first condition of mediation is satisfied, that our antecedent is related to the mediator. Let us do the second condition. Okay, let us look at now our outcome OCB and how is it related to the mediator. Okay, so that is, and I paste the syntax again. So you see in SPSS here, there is a paste option, and you go back to the script. Okay, and you can give your comment, whatever you want, so that you remember why you ran this command. Okay, SPSS, if you work from the graphical user interface, the problem is if you come back after a month, you will not remember what buttons you were clicking. Okay, but if you maintain this script, it will be useful because you will remember the commands that you ran, why you ran those commands, and so on. So here I'm saying I'm checking the regression from AC to OCB. Okay, and I run this now and see what is the relationship. So my R square is 0.28, 28% variance explained. F of the regression is significant. And again, I see that there are two controls that are significant. And what was my major thing that I wanted to test is that this is highly significant. So I see that there is a significant relationship between AC and OCB. So I have shown that my X is related to mediator, mediator is related to my outcome. And so I do the last part, which is the mediation test. So I bring in my OCB and I also bring in the POS. Okay, and I change the sequence so that POS comes first, AC comes second. And I want to see now what is the direct effect, what is the effect of the mediator on Y. Okay, so now I do the third, which is I test the regression between POS, comma, AC and OCB. And when I run this part, I get my last regression, R square 0.32, F of the regression significant. And when I look at these two, I see that both these paths are, so what is the direct path? The direct path is 0.19. It is highly significant, P less than 0.001. And the path from the mediator to the outcome, okay, is also significant. Okay. So we are seeing that there is a significant relationship. Now, what is left to do here is to test whether the indirect effect A into B is significant or not. That is something that you cannot do in SPSS if you are doing it using the regression. So for that, we will go to the process macro. Okay, process macro, and we will install it and we will work with the macro that I have given you. So how will you do it? So you go to utilities. Okay, go to utilities in your SPSS, and there is a option called as custom dialogues, and then you have install custom dialog. Okay, open this custom dialog and it will ask you for where you want to go. So I'm going to the folder, I'm going to the RNP workshop folder that I have created, and you will see that there is this file process v211.spd. This is the dialog, okay, the process dialog, and we open it. So it says there, in my computer, in my machine, this dialog is already installed. Okay, in your machine it will not be installed, so you just say it will automatically install it. For me, it is asking, do you want to override? I say yes. Okay, and it will, you will get a something like this. It says dialog installed to. Okay, so now when you go to analyze and you go to regression, you will see there is a process that starts to appear. Okay, everybody, I want you to pay attention. You in your analyze, regression, and you will start seeing process. Okay, so when we open it, a window like this opens up, right? Okay, and this is what we are going to work with. Now, along with this, what will also be needed is, in the folder that I have given you, there is a file called as templates. Okay, there is a file called as templates. Now, this process macro, okay, this process macro that has been written for SPSS, it analyzes some specific models, and there are many actually. I think there are 78 models that have been coded in this macro. So this is, if you remember, if you can notice, this is a simple moderation. The conceptual diagram, this is the statistical diagram. Okay. Then this is a two moderator, sorry, not mediator. This is a two moderator model. Then there is another, this is called as moderated moderation. Okay. And then we come to model number 4. Model number 4 in SPSS. Okay. And this is what is the mediation model that we are trying to now test. Okay, so when we go to process here, what is our outcome variable? Our outcome is OCB. Our antecedent or independent variable is POS. If you look at this template, what is the M? M is your mediator. So the mediator is effective commitment. And then you have these controls, so you can introduce these as covariates. Okay. And then look at this. So you have to now work with this. You can change this model number. If you want to do moderation, we'll choose model number 1. Here, we are going to work with model number 4. Okay, model number 4 here. So that is what we use. We will also report bootstrapping. I told you that when you do mediation testing. Okay, one of the ways is Sobel t-test, but it has a limitation because it assumes underlying normality. So we also report bootstrap results. Typically 5,000 or 10,000 is good enough. Okay, so I typically report with either 5 or 10,000. So I'm just keeping it at 5 here. And then options. Okay, so we want to report the effect size in mediation. We also want to report Sobel test. So it says model 4 only. Effect sizes model 4. Total effects, yes, we want to report. Compare indirect effects. We have only one indirect effect, so comparing does not make sense. And I will report my output to 3 decimal places. Continue. And then conditioning, this we will do when we come to moderation. Okay, and then you say, okay. Right? Now when you run this, you will get the output. Okay. Now look at this. So we have, what do we have in this result? We have, so what does it say? It says model number 4, Y is OCB, X is POS, M is affective commitment, controls are these, sample size, the data that I have given you has 430, R square of AC regressed on POS, which we had also got, by the way. This is the coefficient. It comes out to be highly significant, P less than 0.001. This is the bootstrap confidence interval, lower limit of the confidence interval, 95%, and upper limit. 0 does not lie here, which is telling us that the coefficient is significant. Similarly, OCB is regressed on both AC and POS. Okay, this is what we had also got when we did it using linear regression. Okay, and they are both significant. Now it says total effects model. What is total effects? When you have OCB regressed on only POS, not POS and AC, but only POS. What happens? This is the total effect. The total effect is 0.339. Now you can also do one thing. The A, okay, the path from POS to AC is 0.584. So the A is 0.584. B, that is path from AC to OCB, that is AC to the outcome, is 0.241. So it is B. So what will be indirect effect? We can compute it ourselves. Okay, we can compute this ourselves. So the indirect effect in this case is going to be 0.584 multiplied by 0.241. Okay, this is the indirect effect, the product of A into B. So let us see what it says. The total effect is 0.339. The direct effect is this. And look at this. This is what we have also computed. It is 0.140. Okay. This is the indirect effect. Is the indirect effect significant? Remember, the test of mediation is that the indirect effect in your research, in your paper, in your data should be significant. The bootstrap interval is telling us it is significant because 0 does not lie in this interval. The lower limit is 0.089, the upper limit is 0.198, and 0 is not here. Look at what is normal. What is normal theory test? This is the Sobel's t-test. Okay, the Sobel's t-test is telling us that the coefficient is 0.140. We know that. What is the Sobel's t? It is 5.2. And is it significant? Yes, it is significant at p less than 0.001. So if you add, and the next thing that I want to show here, remember we said C is equal to C dash plus AB. So the direct effect is 0.199, the indirect effect is 0.140. You add them up, you should get 0.339. So 0.140 plus 0.199 is 0.339. So the total effect is equal to the direct effect plus the indirect effect. Okay, so what have we done? We have broken down. Okay, remember in mediation helps us understand the process. That means there is a direct impact of POS on OCB, but there is also an indirect impact of POS on OCB via the commitment of the individual, and that is 0.140. It is significant. So there is a significant mediation effect. Okay, so that is something that that is reported in research paper. Okay, now, so that is our first hypothesis tested, right? We have found out that affective commitment does mediate this path between POS and OCB. Let us now go to the second hypothesis. And the second hypothesis was that psychological contract breach will actually moderate this path between POS and OCB. So mediation done. Now let's come to moderation and see how it is tested. Okay. Also, before I go further, I just wanted to also show you that it is also possible to paste the process command. Okay. So the only problem here is when you paste in SP, I was telling you, you should maintain your script. The only problem here is that when you say paste, it also pastes the complete code of the process, and it is like a 3000 line of code, okay, that has been written. So I will just demonstrate that. Once you say paste here and you go back to your script, you will see that a code of about 3000 lines has been pasted in the script. Okay, you can delete this. You can delete this code. You see it says process for SPSS v2.11. Okay, you can delete all of this and this becomes your process command. This syntax is actually already given in this file that I have given you, .sps. This is the full syntax of 3000 lines that has been written, okay, for process. So you don't need it here. You can just delete it and you can say this is my mediation analysis hypothesis 1 using. Okay. Right. So we have also pasted the command or what we did using process for, and you can save this. Okay, so I'm saving it. I'm saving it as syntax RNP workshop. Okay, that's the syntax that we have now, syntax file that we are creating. Right, so let us now go and do the next thing, which is test our next hypothesis. Now, in order to do that, what you need to do is remember when we said that if I have to test this model, POS and affective commitment, what I need to also do is I need to now, if I am interested in testing how my POS is going to be, how POS is going to be related to OCB and how the moderation by PCB, I will need to create a product term POS multiplied with PCB. And that will give me the interaction, okay, that I will like to test. So C1, C2, and C3, because this is all direct effect that we are trying to test. Okay, so what I need to do therefore is I need to, in my data file, I need to create a product term POS multiplied with PCB. Okay, so I go to transform and I say compute variable and I call it as PCB or POS multiplied by PCB, POS X PCB, which is POS multiplied by PCB. Okay, so this is the product term that we are going to do. Okay, and I will paste. So when I go back to my script, I write computing the product, right? And I run this. So my product term has been created, and now I have this product, and I can now do my analysis. I go and say regression linear, okay, and I have my OCB, yes, okay, and I have my PCB. Typically what we do is we actually do, whenever we report moderations, we typically do what we call as hierarchical linear modeling. So you enter your controls as well as the antecedents, and then in your next block you enter the product term. Okay, not this one. We created POS X PCB. So that is the product term that you entered. So in block number 1, you just enter these terms, which are the original variables, and then the second is the variable that you have created, which is the interaction term. And in the statistics, you should report what has been the R-square change. Okay. And then I paste and I go back to my script and I say this is hierarchical regression for moderation testing. Okay, and I run this now and I will see the results here. Okay, so what is model 1? Model 1 is when I enter all these variables, and model 2 is in addition to the variables entered in model 1, I also enter the product term. Okay, so the R square is 0.27. Okay, adjusted R square, is it significant? Yes. And then I add one more variable and I look at what has been the F change, and F change is telling me that it is significant. So the moment I see this result, I know that my interaction is significant here. Okay, and I will demonstrate it because the F change is also significant. So this was the first model when you had only the controls and your two variables entered. Are they significant? Well, POS is significant, but PCB is not significant. So C1 is significant, C2 is not significant. But don't worry, remember I told you the test of moderation is C3 should be significant. So let us look at this model now. When we enter this model, now we see that this term is actually significant. This term is coming out to be significant. Okay, so there is a significant moderation effect that is happening. Okay, so there, and we'll come to that in a while. But I want to demonstrate before I go further here. I want to highlight one specific thing. If I were to now write this equation, how will I write it? I will say OCB is equal to some constant plus C1 POS, C2 PCB and C3 POS into PCB plus E of Y, E of OCB. Okay. Now, one thing to note here is how do we interpret our coefficients here? How do I interpret my coefficient C1? What is the interpretation? Now, in regression, when we did not have the product term, we used to say keeping everything else at constant, ceteris paribus. If I change my X variable by 1 unit, Y changes by C1 unit. Okay, that was the interpretation of I'm talking about unstandardized regression equation. However, when you look at an equation where you have a product term, when you have this product term, what is the interpretation of C1? The interpretation here is C1 is if PCB is equal to 0 and POS changes by 1 unit, OCB changes by C1 units. Okay, so what is it? Because there is a product term, I cannot say that if POS changes by 1 unit, because this term will also change then. So I need to tie PCB to 0 and then say if I change POS, how much will OCB change? But remember, in our measurement, we said PCB is measured on a, let's say, a Likert scale of 1 to 7. Okay, it has been measured on a Likert scale of 1 to 7. What is 0 for a scale that had 1 to 7? Okay, that had only 1 to 7. Okay, 0 is not a defined number for a scale of 1 to 7, and therefore saying PCB is 0, when PCB is 0, POS changes by 1 unit, OCB changes by C1 unit is actually absurd. It is absurd because 0 is not a meaningful number on a scale of 1 to 7. Let's assume instead of PCB, this was age. Okay, what we would have said, if age is equal to 0, POS changes by 1 unit, OCB changes by. Age is equal to 0 means the respondent is not even born. Respondent is not even born, and that person's age is therefore 0. So how can age is equal to 0? So that is an absurd understanding, absurd interpretation. Similarly, C2. How will you interpret C2? If POS is kept at 0 and PCB changes by 1 unit, OCB will change by C2 unit. But again, POS is also measured on a scale of 1 to 7. Okay, 0 is not a well-defined number. And so therefore, in order to make our coefficients meaningful in these, especially moderation analysis, okay, what is done is we mean center. Okay, mean centering is done for all those variables which are continuous and which are not just continuous, where 0 is not a well-defined number. Okay, 0 is. So what do? You actually say PCB mean centered is PCB minus its mean. Minus its mean. So it is now mean centered. And POS minus its mean. So the mean of this now is 0. Okay, this variable is now centered around its mean. Okay, so it will take now both negative and positive values. So now if I regress OCB on, let's call this as C1 dash, I call this as POS mean centered, and C2 dash PCB mean centered, C3 dash POS mean centered multiplied with PCB mean centered plus EY. Now, what is the interpretation? I say if PCB mean centered is equal to 0, okay, and POS mean centered changes by 1 unit, OCB changes by C1 dash units. Okay, so what is it that we are doing now? Now we have said that PCB means centered. What does this mean? This variable is actually centered at its mean. So when will this be 0? When PCB will be equal to its mean. Now that is a well-defined number because it lies between the range of 1 and 7. So there is a defined number. So therefore, when you are doing moderation, when we do moderation, we mean center variables where 0 is not a well-defined number. Okay, so that is one reason, because it helps make our make the interpretation of our coefficients more realistic. Okay, the second reason is when you mean center, you also solve the problem of multicollinearity. Okay, because these variables, okay, this variable is getting created by the product of these two, okay, and so it is highly likely that this variable will be correlated with both of these variables. But when you mean center, okay, the problem of collinearity between these variables is also taken care of. So there are people who say that, well, you should do moderation. When you do moderation, you should mean center, otherwise moderation will not come out to be significant. I want to tell you that this is wrong. Okay, mean centering is done in order to make our coefficients more interpretable and also to take care of the collinearity issues that may occur. It is not done, and I will show you in a while that you mean center or you don't mean center. Okay, this is a very important result that we should take account of. In both these regressions, whether I mean center or whether I don't mean center, okay, the coefficient of the interaction term is exactly the same. So if you had significant moderation in this equation, you will also have it in this equation. And if you did not have significant interaction or significant moderation in this equation, you will not have it even if you did mean centering. Okay, so this is a big myth. This is a myth that we should, whenever we are doing moderation testing, we should do mean centering, otherwise moderation will not come out to be significant. Okay, this is not the reason. C3 actually does not change. So let us look at our data, and we just saw that our interaction term when we had not mean centered was minus 0.13. Let us write it down. C3 came out to be minus 0.13 and it was significant at p less than 0.01. Okay. Now, what we will do is we will now mean center. Okay. We want to mean center POS as well as PCB. So the first thing is we want to report what is the mean of these variables. So POS and PCB, what I want to report is mean. So I continue and I paste. Okay. This is I will write it down. I am saying I am mean centering POS and PC. So if I run this, I will get the mean of 4.912 for POS and PCB it is. So what do? I go to analyze. Here I go to my data, transform compute variable, and I say POS mean centered is equal to POS minus the mean was 4.9120. 0.9120. Okay, and I paste it. And similarly, I say compute, I say PCB mean center is PCB minus the mean was 2.4656, 2.4656, and I paste it. And I go to back to my script, and I'm saying mean centering POS, so I run both these commands because I want to mean center both of these. So my variables are now mean centered. So you see now you have these two variables that have been mean centered. Okay, you can verify in the data file I had already created, but after even with this it is the same 1.21, 0.53. So they are mean centered around, they are now centered around their means. The last thing is now we have to create the interaction term or the product term using these mean centered. So we will now say again compute variable, and I say POS multiplied with PCB, and I will call it as POS mean centered multiplied with PCB mean centered. Okay, so I now multiply these two terms. Paste it, and I say creating the product term. Okay, and I run this. Okay, and now we come to our analysis, regression. Okay, and instead of, so we go to our block, instead of non-mean centered variable, we are going to include the mean centered variable, and in the next block we will introduce the mean centered product term. We had already written R square change, so that should be fine. And I now write testing moderation using the mean centered variables. Okay, and I run this. Okay, now I want you to focus on this coefficient. Okay, this is, so we get our R square, okay, our F, these will not change, they are exactly the same. Okay, and then look at the coefficients. Look at the coefficient of this term. This was 0.130. I had asked you to write it down. Okay, and you can verify. And what I want to prove here is whether we mean center the variables or we don't, we get the same coefficient for our interaction term. But this is a better thing to do because it makes our coefficients better, and also the interpretation, the collinearity issues are tackled in this. Okay, so what is it telling us? That there is a significant moderation here. Okay, and we have proved by this result. Now we come to doing the same thing using process. So you go to process. Okay, remove, take out. Okay, we want to do OCB. We want to now bring in the mean centered. What is our M? Our M is PCB mean centered. Covariates are these. And what is the model number? The model number is model number 1 here. Okay. Yeah, so I will change it to model number 1. Options. Okay, I want to generate data for plotting. Okay, I told you that we will always plot. So I continue conditions. Typically, we plot, in order to plot, we typically use mean plus minus 1 standard deviation. Okay, I can paste it, but I will also get 3000 line of code in my script, which I will have to now remove. Okay, so I will remove all this piece of code update process. Okay, and I will say moderation testing. Right now, this is the same thing that we have got. Look at the interaction, and the coefficient is the same that we had also got. Now it says conditional effect of x on y. What is the conditional effect of x on y? Conditional effect of x on y. If you look at this equation, what is the conditional effect of x on y at the moderator? It is c1 dash plus c3 dash times pcb mean center. Okay, c1 plus c3 m. Right, what is our c1? C1 in our analysis is the coefficient of POS, which is 0.355, minus C3 is 130 times PCB mean centered. This is the effect, conditional effect. Now you can, okay, now you can put in the two values of PCB, that is minus mean minus 1 SD, so 0.678, okay, and you can put in plus 0.678 into this equation. So if we put in minus 0.678, what do we get? 0.355 plus, so if I multiply minus 0.3 with minus 0.678, what do I get? 0.088, and I add this up, what do I get? I get 0.4. Okay, look it up in your output. Okay, this is exactly what we are. This is exactly what we are getting. Okay, so this is called as the conditional effect. And now you can also use this data for plotting. You can use this data for plotting. I had actually I have uploaded a Excel sheet where I had drawn it by myself. Okay, so I had copied all these coefficients and then done it, but I will yeah, so you can just go over this, but you can also do a simple stuff. You can simply plot this, okay, using this. Okay, let me not do it here. Let us do it. So we copy that data from process here, and this is what we get. So this will be pasted in a text. So you go to data and then say text to columns and just say next, next, and finish. And now it has been broken down into 3 columns. Previously it was coming out as a text. So we want to look at when PCB is low, so moderator is low, what happens to the plot? When PCB is high, what happens to the plot? Okay, so to plot any line, there is just 2 points that are needed, but you can also use 3 points. So how do you do it? Insert and then go to this chart. You will have to, as I was telling you, you will always have to plot this kind of a chart in your research papers. So you say add series, okay, add. So I call this as the first series I say PCB is low. When psychological contract breach is low, okay, yeah, I will edit. And what are my series values? The series values are these. So this is the line. Then I go to add again. I want to add another series in this chart. I say PCB is, sorry, I will say PCB is equal to high. And what is the data? The data for PCB high is this. Okay, so I get this chart. And I can also edit the horizontal axis. So I call this as these three numbers. Okay. You will see in the quick layout, I typically, whenever I plot, I really like the 10th outlook layout here. Okay, so you can give chart title, you can give the axis title. So our axis here is y-axis is OCB. Okay, the x-axis is our POS. Okay, and we can delete all these lines. You can edit the chart area. Okay, so you can go to this option here, axis options. So it starts, you can make it start from, instead of 0, you can make it start from, so that it looks, yeah. So now you see that the lines are diverging. Okay, you can also play around. Okay, you can make this a solid line. No, sorry, not the fill, but line. So you say solid line and make it black in color. Okay, so now you have a solid line here. Similarly, the x-axis, you say solid line, black color, right? Here we go. And then if you are putting it in your research papers, colored graphs are not put. Okay, so you have to make it black and white. So this changes the line to black and the other also black. So how do you differentiate the two lines? You change the line type. Okay, so now we know that this dash line is when the moderator takes the high value. The solid line is when the moderator is taking the low value. So what does this show? As POS increases, citizenship increases, but the change is lesser when there is a psychological contract breach. When the psychological contract breach is low, then citizenship increases much faster, okay, faster than when the psychological contract breach is there. So this proves that there is a moderation of the relationship between POS and OCB. So this is the proof. This is how you will have to, this is all that you will have to do when you are doing your, when you will be writing your second hypothesis. Okay. Now let us come to the last one, which we are talking about, conditional process model. So the model that we want to test is this kind of a model. Okay, so let us look at the first thing if we want to do it using process. Now the conditional process happens using only the process macro in SPSS. In R, when I do my analysis, I typically use R, and R can do, as in you can do it, but in SPSS, you will have to use this macro if you are trying to do conditional process modeling. So let us explore which model actually reflects our research diagram. So model number 7 comes close to this, but we want the arrow. Yeah, model number 8. Look at this model and look at this model. Okay, so this is exactly the model that we are trying to test. So I go back to my data and I say, go to analyze, regression, and process. Okay, I select and I go down to model number 8. Okay, because that's the model that I'm interested in testing. Now, what is the additional thing that I want to add is I want to add W and I want to add M. Okay, so what is my M? M is my mediator. So I add AC, right? Effective commitment is my mediator, right? So that is my M. And what is my W? The W is psychological contract breach. So I go back and I choose my psychological contract breach and I bring it to my proposed moderator. Okay, so that's sort of right. So what we had done up till now was we had tested our two hypotheses. We had done the mediation, we had done the moderation, we had done this plot, okay, where we looked at the moderating role of psychological capital breach for the relationship between POS and OCD. So the next thing, yeah, let me share my screen. Okay, so we had done the two hypotheses. The first two hypotheses we had tested. We had plotted this graph. We had tested the moderating role of PCB for POS and OCD relationship. Now the last thing that we were coming to was this third hypothesis, which is the moderated mediation hypothesis. And I said we will go to, this is where we lost contact. So we had come to model number 8 because if you remember, we had said that this is the diagram, this is the template that matches what we are trying to do here. And so we go to model number 8. Our outcome variable is OCB. The mediator M is effective commitment. The independent variable is the mean-centered POS. Why mean-centered? Because remember, we will be doing the product of POS and psychological contract breach, and I told you that you should always mean-center in order to make the coefficients interpretable and also to tackle the collinearity. So we have introduced our moderator W, okay, AC. Options, now we don't need to do because these are only applicable for the first 6 models, okay. So what we will do is just leave it as it is. Conditioning, we'll continue with a mean plus minus 1 SD. And now I will paste the command again in my syntax file, okay. And we know that there will be 3000 lines of code that would be printed, so we will remove that code from our, and we will add the comment that this is our moderated mediation. Okay. Now when we run this, we get the output. We're waiting for the output. Yes, here it is. Now model number 8. Okay, so let us look at what is it that we are getting. So we are getting model number 8. That is fine. Our Y is OCB, X is POS, mediator is AC, and the W here is PCB mean set. Our sample size is 429. So the first outcome that we are looking at, so we are now focusing on this part of our model. Okay, so this part where we are looking at POS, outcome is AC and the role of psychological contract breach here. and that is what is given. So you have the constant, then you have the POS coefficient, it is significant. PCB direct path, it is significant at p less than 0.01. And now you get the interaction term, which is minus 0.206. Okay, the interaction is POS multiplied with PCB. Okay, so there is a significant interaction, and this effect is negative, which is what we had theorized also, that higher the PCB, okay, if PCB psychological contract breach is high, then the effective commitment should be low, and that is what the negative sign here is telling us. Rest are the control variables. Then we go to the outcome, the OCB. Okay, here you have the path from the mediator coming in, which is significant. Okay, then you have the POS PCB. Okay, PCB is not significant, but let us look at what happens to the interaction. Interaction term is significant at p less than 0.05. Okay, so at p less than 0.05, the interaction 2, which is again POS multiplied with PCB. What is the part of the model that is being tested in this? We are testing this part. So OCB is the outcome. So you have a path from effective commitment, and you have a direct path coming from POS, and then you have the moderator PCB. So you will therefore have a path from PCB as well as the product POS and PCB. Right? Now let us look at the effects. Okay, so what will be the conditional effects here? The conditional direct effects. So the conditional direct effects would be, we were talking about this, and yeah, so now the conditional direct effect, let us look at the conditional direct effect now. Okay, the output of our model tells us, so if you are talking about POS to OCB, you have PCB also, and you have POS into PCB. Okay, the coefficient of POS here is 0.204. Then the coefficient of PCB is minus 0.065, and 0.204 is significant at triple star here, implies P less than 0.001. Okay, and POS to PCB, the interaction, it is minus 0.084. It is significant, right? Double star is less than 0.01, and single star is P less than 0. Okay, so what is the theta x to y conditioned upon, or let me call it as POS to OCB, which is conditioned on PCB, is given by 0.204 minus 0.084 times PC. Okay, now the PCB we know takes two values. Low value is minus 0.678, and the high value is mean plus 1 SV, that is plus 0.678. So what will this be at theta POS, when PCB is equal to minus 0.678, we can write it is 0.204 minus 0.0 So I'm just multiplying it, so I can also write this as 0.084 multiplied with 0.678. So if you solve this, let me just do it quickly. 0.084 multiplied with 678. It is going to be 0.202 plus 0.057. And if you add this, you get 0.265. Right? And this is what we are getting at minus 0.678, the direct effect. Similarly, you can put in plus 0.678, you will get. So what is it that we are seeing? As the psychological contract breach moves from low to high value, the direct effect of POS on OCB decreases, and that is the moderation that we are talking about. Okay. Similarly, the conditional indirect effect. Now, let us come to the conditional indirect effect. So I'm again coming to my whiteboard. Let us draw it and let us write down what is the conditional indirect effect now. Okay, so this was for the direct effect. Let us now draw a similar diagram for, so you have POS to AC, right? And you have OCB on there. This is, and then there will be a path from PCB, and there will be a path from POS multiplied with PCB. Okay, so, and there are all these coefficients here also, PCB and POS. Okay, so this is, remember we said this is A1, A2, A3, and we said this is B. This is C1, C2, and C3. Okay. Now, what are the coefficients? So C1, C2, C3 we can write. It is already here. So C1 was 0.204 triple star. C2 was minus 0.065, and it was not significant. And this was minus 0.084 single star. Right? Yes. Okay. And now we'll also write down what is our A1, A2, A3, and B. So we look at our output here, and right. So what is our B? B is the path from AC to OCB. So this is 0.223, and it is significant at triple star. Then what is A1? So we go back to when the outcome was AC. What is A1? A1 is the path from POS to AC. So this is 0.679. It is significant at triple star. Then what is A2? A2 is the path from PCB. So this is 0.197. It is significant at double star, P less than 0.01. And then the interaction term is minus 0.206. Minus 0.206. What is it? It is significant at triple star. Right, so now we have completed our diagram. this is what we have got. So we have written down our values of A1, A2, A3 and AC, and the path from AC to OCB, which is B. So we said, what is our theta x to m now, which is conditional on W, which is theta POS to AC, conditional on PCB, it is A1 plus A3W, right? So this is the effect of POS, the antecedent to the mediator. It is given by A1 plus A3W, which is given by 0.679 plus, it is minus 0.206. So let me write it here, minus 0.206 times AC. Okay, then theta m to y, which is theta AC to OCB. Now this is not conditional on anything, which is equal to B, which is equal to 0.223. So what is our conditional indirect effect? Okay, so what is going to be our theta x to m to y, conditional on W, indirect effect? It is going to be A1 plus A3 W times B, okay, which can be written as 0.679 minus 0.206 PCB whole multiplied with 0.223. Now we know PCB takes two values, so I can say theta x to m to y when W is minus 0.678 is going to be 0.679 plus minus 0.206 multiplied with minus 0.678 whole multiplied with 0.223. If I were to solve this, okay, 0.206 multiplied with 0.678 plus 0.679 whole multiplied with 0.223, it will come out to be 0.183, about 0.1. Similarly, the indirect effect, which is now conditional, so theta x to m to y, 0.678, which is 0.679 plus minus 0.206 multiplied with 0.678 whole multiplied with 0.223. So what does this become? It becomes okay, and let us see what the software tells us in terms of the indirect effect. Okay, when we go down, we say AC, when PCB is low, it gives 0.182. We have also written 0.18, we have written 0.183. Is it significant? The indirect effect is significant because the zero does not lie in the confidence interval. For high, it is 0.120. This is what we had also got. This is also significant. What we see is as the psychological contract breach moves from low to high, the indirect effect starts to reduce. That means the indirect effect is conditional upon the value that PCB is taking. And that is the conclusion that we write. So when I write this paper, in the paper, you see we report this in terms of our table. So we report all of this, and then this is what we have written, table number 4, moderated mediation result for perceived organization support across levels of psychological contract breach. So the conditional indirect effect, when the response variable, the outcome variable was OCB, the mediator was effective commitment, low value of the moderator, the effect was 0.20, okay, and it was the bootstrap confidence interval suggested it is significant. At high levels of the moderator, it reduced, it continued to remain significant, but the indirect effect has reduced. So what does this show? It shows that the process that we are talking about does not happen unconditionally. It is conditioned on the value that the moderator is taking. As the moderator takes a higher value, your indirect effect also starts to change. And that is the whole idea of talking about the conditional process analysis. You can read further papers. In all these papers, in all moderated mediation papers, you will find a table like this. You see in another paper, moderated mediation results for job characteristic across levels of conscientiousness, the conditional indirect effect, low value of the moderator, high value of the moderator. Okay, and you show that the indirect effect also changes. You report the confidence. Okay, so this is typically what is reported. You have diagrams like these or conceptual diagrams like these where you are saying that the process that we were talking about is conditioned on certain variables, right? So what is to conclude what we have learned? We have learned the idea of mediation, okay, which is the process. We have learned the idea of moderation, which is talking about testing boundary conditions, and then mixing the two or combining the two in order to get to this idea of moderated mediation, which is the conditional indirect effect or the conditional process. Okay, so I hope you will you would have gained some insight based on what we have discussed. Please feel free to go through these papers, try out the example again that we have done in the class. I will also be, in case there is any other thing you may want to talk about, feel free to write to me and I will be happy to answer your queries. The book by Andrew F. Hayes is a very good text, okay? And the book covers broadly the ideas that I have tried to cover in this time of 3 hours that we. That is it from my side. Once again, apologies to all of you for the disruption that happened. There are things that are beyond our control and we have to make the best use of what we have. Yes.
Professor, would it be possible to attach the output files and the syntax in Google Drive?
Yes, I will do that.
Thank you, Professor.
And I will. It is not a Google Drive per se, but so maybe what I will do is, can I share it right now through the, okay, I will figure out, I will maybe upload and then send out a link again.